Chapter 16, question 7, is asking us to draw some peptides. It says, draw the condensed structural formula for each of the following peptides and give its 3-letter and 1-letter abbreviations. So up to this point in chapter 16, we've talked about amino acids. And amino acids are like individual links. If you put them together, then you get a chain. Now, if it's a small chain made up of between from 2 to 50, as a rule of thumb, 2 to 50 amino acids, 2 to 50 links, then it's called a peptide. So we're going to draw some small peptides, ones that have less than 50 amino acids in them. If you have more than 50, then you would start calling the chain that had so many amino acids in it a protein. So a peptide and protein, there's not a hard and fast rule for the difference between them. They are both strings of amino acids that are bonded to each other. But as a rule of thumb, if you have less than 50 amino acids, it's a peptide, and more than 50, it's a protein. So we're going to be drawing peptides. Now, the peptides are made up of amino acids, and so this is going to really be similar to drawing amino acids. The first thing you have to do is to recognize how many amino acids you have. And before we get into that, let me just make sure that we're all on the same page about one other term. A carbon double bonded to an oxygen is not a functional group itself, but it's a motif that appears in a lot of functional groups. It appears in the carboxylic acid that are in amino acids, and so it's going to appear in these peptides. I'm going to refer to that as a carbonyl. Carbonyl. So I'll say nitrogen, carbon, carbonyl, carbon. And that's referring to this carbon right here. Okay. So the first thing we need to do is to figure out how many amino acids we have. And to do that, every time you see a YL, that's the end of an amino acid. There's only one exception. The exception is phenylalanine. If you look at the table 16.2 that lists all these 20 amino acids, if you look, you will see that phenylalanine is its own amino acid. But for every other amino acid, a YL indicates that that's the end of one amino acid. So here we have a YL, that's one amino acid, and there we have another name, and so that's 2. So here we have 2 amino acids. Okay, for every amino acid, you're going to draw a nitrogen, a carbon, and a carbonyl. So we have 2 here, so I'm going to draw nitrogen, carbon, carbonyl. So that's 1. And actually, this is 1. And then nitrogen, carbon, carbonyl. And that's 2. So what's happening here is the amine on one amino acid is connecting to the carboxylic acid on the other one, and it's changing it to an amide. This is a reaction that we saw in the organic chemistry section of the course, and that bond right here that's connecting the 2 amino acids to form a peptide is called a peptide bond. Okay, so we have our 2 sort of backbones. Next, fix the ends. The ends need to resemble the ends on these amino acids. The left end has to have the H3 and the plus charge. So H3 and the plus charge. The right end has to have the 2 oxygens and a minus charge. Now we've already drawn one of the oxygens here, so we just need the other one and the minus charge. So we've filled in the 2 ends. Now, all of the carbons need 4 bonds. To each of the carbons in the middle that don't already have 4 bonds, and also to the nitrogens in the middle, you want a bond going down to a hydrogen. For each of the carbons, they need a bond going up, and that's going to be the R group. The R group will be given by the name. Now, alanyl The amino acid that most closely resembles that name is alanine. And so the R group for that is CH3. So we'd write CH3. For cysteine, the amino acid we're looking at is cysteine. On this table, it's right here. And the R group for that is CH2SH. So we have CH2SH. And that is the structure for this peptide. This is made of 2 amino acids, so it would be called a dipeptide. Just to emphasize what we've got, we have alanine, that's this portion right here, that's alanine. And then we have cysteine, that's this portion right here, and you can see that they're connected by the peptide bond in between. Now this is also asking for its 3-letter and 1-letter abbreviations. So the 3-letter abbreviation for alanine is ALA. And while we're at it, the 1-letter abbreviation is A. So we can also write ALA and A. And the 3-letter abbreviation and 1-letter abbreviation for cysteine is CYS and C. So we could write CYS and C. And in each of these cases, all of these symbols are representing the same thing. So that is the condensed structural formula and the 3-letter and 1-letter abbreviations for alanylcysteine. Let's try to do it for seryl phenylalanine. Remember, the first thing you want to do is to figure out how many amino acids you have. Every time you run into a YL, it's the end of an amino acid except for phenylalanine. Phenylalanine is the one amino acid that has a YL in its name. So, this is seryl, there's a YL, the end of amino acid, and here phenylalanine, that whole thing is 1 amino acid. So again, we're dealing with 2 amino acids. For each amino acid, write a nitrogen, a carbon, and a carbonyl. So that's 1 amino acid. For the second one, nitrogen, carbon, carbonyl. That's our second amino acid. You want to make the ends look correct. So add the H3 and the plus charge to the left end and an O minus to the right end. To all the carbons and nitrogens in the middle that are missing bonds, so not the carbonyl carbons, but the other carbons, draw a hydrogen going down, also to the nitrogens in the middle. The carbons on top need the R groups, and those depend on which amino acid you're dealing with. Seryl, the amino acid whose name most closely resembles that, is serine. The R group there is CH2OH. So that's what we put on top, CH2OH. For phenylalanine, we know that's phenylalanine, and the R group here is a CH2 and a benzene ring. So CH2 and a benzene ring. So that's 6-membered ring with a circle inside. And there you have it. The condensed structural formula for seryl phenylalanine. Seryl is referring to this part right here. And phenylalanine is referring to this part right here. The bond that's connecting them is the peptide bond. This is a dipeptide. It's a peptide made of 2 amino acids. Now, we could also give the question is also asking for the 3-letter and 1-letter abbreviations. So for serine, the 3-letter abbreviation is SER, the 1-letter abbreviation is S. So we could have S-E-R, and S. For phenylalanine, the three-letter abbreviation is PHE, one-letter abbreviation is F. So we'd have PHE and F. And so in each of these cases, in all of these diagrams, you're representing the same dipeptide, phenylalanine. Okay, let's try it with glycylalanyl-valine, C. Every time you see a YL, except in the case of phenylalanine, it's the end of an amino acid. So glycyl, there's one, because you see a YL. Alanyl, there's another, because you see a YL. And then valine. So we have 3, 1, 2, 3 amino acids. For each amino acid, you want to write a nitrogen, a carbon, and a carbonyl. So that's our first amino acid. For each amino acid, you want to write a nitrogen, a carbon, and a carbonyl. So that is our second amino acid. For each amino acid, you want to write a nitrogen, a carbon, and a carbonyl. That is our third amino acid. First, then, fix the ends. The left end should have that H3 with a plus charge. The right end should have the O minus. In the middle, the carbons that only have 2 bonds and the nitrogens all need a hydrogen. So put a hydrogen on each of those. Notice I'm not putting a hydrogen on the carbonyl carbons. The carbons that are in the middle need a bond going up to their R group. And what that is depends on which amino acid you're dealing with. The first one is glycyl, and the amino acid that most closely resembles that is glycine. Glycine is in this top left position. So we can see here that the R group is just an H. For the second amino acid, alanyl, that most closely resembles alanine, we can see the R group is CH3. For valine, we can find that's up here. You can see the R group is CH with 2 CH3s on it. Oops. CH3, CH3. And so there we have our peptide. This has 3 amino acids, so this would be considered a tripeptide. So glycyl is this part right here. The alanyl will be this middle part here. And valine is this third part here. So that is a tripeptide. That's the tripeptide there. The question is also asking for the 3-letter and 1-letter abbreviations. And so for glycine, the 3-letter abbreviation is GLY. The 1-letter abbreviation is G. So we can put GLY and G. For alanine, the 3-letter abbreviation is ALA, the 1-letter abbreviation is A. So we can put ALA and A. And for valine, the 3-letter abbreviation is VAL, the 1-letter abbreviation is V. So we can put VAL and V. And so again, we have valine, we have alanine, and we have glycine. So that is that tripeptide. All right, let's try to do D. Vale Isoleucil tryptophan. Every time you see a YL, it's a new amino acid, except in the case of phenylalanine, which we don't have here. So Vale, there's a YL, that's the end of one amino acid. Isoleucil, there's another YL, the end of that amino acid. Tryptophan, we're dealing with 1, 2, 3 amino acids. For each amino acid, write a nitrogen, a carbon, and a carbonyl. So that's our first amino acid. For each amino acid, write a nitrogen, a carbon, and a carbonyl. That is our second amino acid. For each amino acid, write a nitrogen, carbon, carbonyl. That is our third amino acid. Make sure the ends look appropriate. The left end should have the H3 and a plus charge. The right end should have an O minus. Each carbon in the middle, not the carbonyl carbons, but the other carbons, and each nitrogen needs an H. The carbons in the middle that are not the carbonyl carbons need a bond going up for the R group, the group that makes each amino acid different. That depends on which amino acid you are. So Vale most closely resembles valine. And the R group is CH with 2 CH3s. So CH with 2 CH3s. Isoleucil most closely resembles isoleucine. Its R group is a CH with a CH2 and CH3 on top, and a CH3 to the left. So CH with CH2, CH3, and then a CH3 to the left. And tryptophan has a complicated R group. It's this right here. It has that CH2, a 5-membered ring with a nitrogen on the top, and then a 6-membered ring, a benzene ring, so a circle on the side, has a double bond there, and then above the nitrogen you just have that one hydrogen. And that is our peptide. This is made of 3 amino acids, so this is going to be a tripeptide. Valine is this part right here. Isoleucine is this part right here. And tryptophan is this last part right here. And so this has 1 peptide bond, 2 peptide bonds. And that is made of 3 amino acids, so it's a tripeptide. Now the question is also asking for the 3-letter abbreviations and the 1-letter abbreviations. And so we'll write those underneath here. For valine, that will be VAL and V. For isoleucine, that will be ILE and I. And for tryptophan, that will be TRP and W. And those are the condensed structural formulas for those peptides.